these are the notes for section 2.2 part 2, and we're going to be talking about function notation, domain and range again, and piecewise functions. So the first thing I want to mention is function notation, which we've talked a little bit about before. This is where you, instead of writing y equals or something like that, we write something like f of x equals, let's say, 2x plus 1. Now, the reason we do this is because it indicates what output corresponds to a given input. So remember in our last section of notes, we were talking about input and output. So a function notation really tells us what our input is. In this case, we're inputting x, and then whatever we get when we input x is our output. You can also remember that we talked about that phrase Dix-Roy. That helps you remember that the domain has to do with the input, which are the x values, and the range is the output, which is the y values. So we're inputting x, we're getting out what the y values are. And I say y even though in this equation we don't use y, because on a graph it would be the y value. So the way you say this that I just wrote is f of x equals 2x plus 1. You could also say the value of f at x equals 2x plus 1. That's how you read that. It's really, really important to note that f of x does not mean f times x. Okay, it means that we're inputting x into the function and we're going to call it f. The most common thing to call a function is f of x, or you might call it g of x. Those are the two most common, but you can use any letter. So just keep in mind that what you are putting in is your input, that's usually your x, and what you get out is your output, that's your y. So, for example, you're going to get some problems like this. It says, find each indicated function value. Really, all this does is it tells you what to input into your equation, except for one, and that's letter E. That one's kind of a special one. So, on all of these problems, they're giving you something to input other than x. On A, they tell us that we want to find f of 5 for f of x equals 3x plus 2. So we want to find the value of this function f when our input is 5. So where we see an x, we're going to put a 5 instead. Okay? So that means we're going to plug it in right there into our equation. So f of 5 equals 3 times 5 plus 2. And 3 times 5 is 15, plus 2 is 17. So the value of f when x is 5 is 17. That's our output when the input is 5. Let's try another one. Now we're going to input a negative 2. So we're going to find g of negative 2 for g of r equals 5r squared plus 3r. So we're going to be inputting a negative 2 wherever we see an r now. Our input used to be r, we're changing it to negative 2. So we need to put a negative 2 right there and right there. So g of negative 2 equals 5 times negative 2 squared. Notice that I put it in parentheses because we want that whole thing squared because the entire r was squared before. So I'm going to square negative 2, which means I'm going to do negative 2 times negative 2. So I've got 5 times negative 2 squared plus 3 times negative 2. I put an r in both, I put a negative 2 in both those places where I see an r. So now let's evaluate that. Remember that we need to use order of operations. There's no operations in parentheses, but there is an exponent. So negative 2 squared, that's negative 2 times negative 2, times itself, that's 4. So I'm really doing 5 times 4 plus 3 times negative 2. I'm going to do a little of this just out loud because I don't have room to write it. 5 times 4 is 20. 3 times negative 2 is negative 6. So I'm doing 20 plus negative 6. And that's like 20 minus 6, so our answer here is 14. I should have given us some more room on these ones, shouldn't I? This next one's a little weird. Letter C is weird because it says h of 4 for when h of x is 7. So we're going to put a 4 where we see x. The only thing is, in your actual function over here, there's no x in it. It's just 7. That's really just saying it equals 7 no matter what. You don't really input anything. It means no matter what you input, it's 7. So there's nowhere to plug that 4 in, so the answer is just 7. 7 no matter what. D is where we start to get to the more challenging problems. So, and actually the other thing is that I wrote this incorrectly. So on D, let's change this to, it should say find f of a plus 1 for f of x equals 3x plus 2. Sorry about that. So this means that we're going to change our input. All right, we're going to, I'm trying to make my line thinner here, but I can't remember how to do it. Here? Oh well. All right, so we're going to change our input to a plus 1. So whenever we saw an x before, now we're going to write a plus 1. So here, I'm going to write 3 instead of x. My input is now a plus 1, and I want to put it in parentheses because I want to make sure it's all multiplied to the 3. And then plus 2. Now in this problem, we're not going to be able to get rid of that a completely, so we're just going to simplify this. Let's distribute first. So 3 times a is 3a. 3 times 1 is 3. And then we have this plus 2 on the end. And we can simplify that a little farther because we can combine our two constants, 3 and 2. So we have 3a plus 5. And we can leave that as a solution here because we don't have anything to input for a. It just told us to replace x with a plus 1. All right, E is really tricky. This is the last one we're going to do together. I want you to try this the last one in this try box on your own. But for E, it says that we're finding f of a, and then we're going to add 1 to the function. So the only thing we're changing for our input is what's in parentheses after whatever you're naming your function. In this case, it's a capital F. So we're going to put an a wherever we see an x because that's our input. So I'm going to change this to 3a plus 2. But if you notice this plus 1, it's after the function. The function is f of a, and then it says add 1 on to the end of it, basically. So we're going to add 1 on right here on the end. So if it's not in parentheses, you want to add it on to the end of the function. So now we can simplify this because we can add 2 and 1, and we end up with 3a plus 3. So you only change in the function, you only change the x in the function or whatever's in it for what's in the parentheses, and then anything outside you add on or subtract or multiply at the end. So I want you guys to try that last one. Go ahead and pause and try that last one. All right, we're going to do another example here. It says let f of x equal 3x minus 7. The first question we're going to answer is what output corresponds to an input of 5? So remember that input refers to x. So I want to know when my input, my x, is 5 because it said an input of 5. So this is really simple. You just plug 5 in for x. So we're going to do 3 times 5. I'm taking that from right here. 3 times 5 minus 7. So that's 15 minus 7, and that is 8. The next one's a teeny bit trickier. It says what input corresponds. So we're trying to find what x corresponds to an output of 5. So an output is like what the equation ends up equaling. So it says the output is 5. The equation ends up equaling 5. So we're going to write 3x minus 7 equals 5. And we need to find x. We need to find the input. So now this is just a typical algebraic equation. We'll get x by itself. We have to undo adding and subtracting first. So we'll add 7 to each side. We end up with 3x equals 12. And we know that we can divide by 3, or we just know that 3 times 4 is 12. So x is 4. That's our input. All right, we're going to move on to some domain questions now. These ones say, for each equation, determine the domain of f. Now, if you remember, we had some equations like this before. The main thing that we learned is, well, there's two things. We learned that when we're looking for the domain, the question yourself, and I want you to write this down. The question you're asking yourself is, what can x equal? Okay, so you're asking yourself, what could x be? What are all the things x could be? And you want to think, is there anything I can't plug in for x? And if you remember when we talked about this in our last section, there were two things that we talked about. Okay, we learned that, I'll write this over to the side over here. Okay, the denominator of a fraction, oops, spelling that wrong. The denominator of a fraction cannot equal 0, and you can't have a negative in a square root. So denominators cannot equal 0, no negatives in square roots. Those are the two main things. So for question A, we're wondering, is there anything I couldn't take the absolute value of? What could I plug in right here? What numbers could I take the absolute value of? Well, I could take the absolute value of a negative, right? It would just turn positive. I can take the absolute value of 0. I can take the absolute value of a positive number. I can take the absolute value of anything I want. So the answer to this one is all real numbers. The domain is what x can be. The domain of this is all real numbers. I can plug in anything I want because I can take the absolute value of any real number. So that one's like, it's fine. You can plug in whatever you want. Now the second one, notice that we have an x in the denominator. So there's going to be some restrictions on x because it's not that x can't be 0, because we would do 2 times 0, that's 0, minus 6 is negative 6. If x is 0, the denominator is negative 6. That's totally fine. But we can't have that entire quantity in the denominator equaling 0. So let's see what would make that equal 0. If 2x minus 6 equaled 0, we can find what x value makes that happen. We can add 6 to each side. We can divide by 2. And we can see that x is 3. So we know that when x is 3, the denominator is 0. That makes sense, right? 2 times 3 is 6, minus 6 is 0. So we cannot let x equal 3, because that would make the denominator 0, and that would be bad. So we cannot have the number 3 in our domain, because the domain is what x can be. So the way your book writes this is in set builder notation. So the way we would write this is all real numbers x such that x is a real number and x does not equal 3. So you want to think about two things. You cannot have the denominator of a fraction equaling 0, and we cannot have the inside of a square root equal 0. All right, we're going to fill in this table in the back about domain. Oh no, did I forget to put it on here? Oh no, here it is. All right, so domain of a function. We're going to fill this in. So first of all, if we're talking about a table or a bunch of points, or a set of ordered pairs, the way you find the domain, it's just the set of all first coordinates. Okay, and you might want to write off to the side, it's just the x values. So if I just give you a big table or a bunch of points, the domain is just all the x values. If we're looking at a graph, the domain it's the same thing. It's the set of all first coordinates. It's all the x values that you see on that graph. How far does the graph stretch from the right to the left? That's the domain. Now I want you to remember that if you see a line on your graph and not just points, a line is infinite points. So you're going to have to give me a range of values for the domain, like anything from 0 to 3, if there was a line that went from 0 to 3, something like that. If we're just looking at an equation and we don't have a graph or anything of it, then the domain is the set of all numbers for which the function can be calculated. Those are the problems that we were just doing. We gave you an equation, and you would have found all the numbers that we could plug in for x, and it would still work, basically. And then lastly, in an application, which is a real-life situation, the domain is the set of all numbers that make sense as inputs. So the domain is anything you could plug in. So for example, let's say that we had a situation where we said we're going to have an equation called m of x, and it's going to represent the money that you make after working x hours as a babysitter. And let's say you get $10 per hour, plus they pay you $15 just to show up. Right? In this situation, since x is the number of hours, your domain might be something like, I'll write an interval notation. You're not going to babysit for 0 hours, right? So we probably wouldn't include 0. And maybe you'd range all the way up to infinity. That would be kind of weird because that would mean these people just like left their kid with you and you're babysitting them forever. I hope that doesn't happen to you. So instead of infinity, maybe the most you babysit a kid is like all day. That's even kind of a big deal. Hopefully the kid's good. So maybe something like that. If it's a word problem, you're going to think about what makes sense to put into that equation. Last, we're going to talk about piecewise functions. These are really easy, to be honest. A piecewise function is a function that is defined by different equations for various parts of their domain. So what that means is that you might have a graph where as you're reading it, maybe it has a line like this right here. Maybe this is -1, -2, -3 right there. Maybe it's defined as this blue line from -3 up to -1. But then starting at -1, we define it as this green line. That's what a piecewise function looks like. It's like a graph that's broken up into pieces, or a function that's broken up into pieces. So for example, we're going to find the function value for the function f given by f of x equals, and you can see the two lines here. There's 2x and x plus 1. The equation is 2x when x is less than 3. And the equation is x plus 1 when x is greater than or equal to 3. So what you're going to do is you're going to look at what they want you to find. On problem A, we're looking for when our input, or our x, is 4. So that falls into the second category right here because 4 is greater than or equal to 3. So we're going to use that equation right there, x plus 1. And we're just going to plug a 4 in for x. So it's just 4 plus 1, and our answer is 5. So the last thing I want you guys to do is I want you guys to try finding f of -10. I don't know why there's a little line after it, and that I know that b is kind of confusing. So I just want you to find f of -10. Figure out which of these two equations to use, and then plug -10 in. All right, that's it for these notes. Come to class with any questions you have.